welcome to our journey through the fascinating world of geology. Before us lies a narrative etched in stone, water and fire, a story that spans billions of years, revealing the very fabric of our planet. It's a tale of colossal forces and delicate artistry, of silent, slow transformations and sudden, dramatic upheavals. Geology is not merely the study of rocks, it is the chronicle of Earth itself, a key that unlocks the secrets of its past, the dynamics of its present, and even the possibilities of its future. Without this understanding, we are but fleeting visitors, unaware of the immense history beneath our very feet. Today we'll explore the various branches that make up this incredible field of science. Each branch, like a tributary feeding a mighty river, contributes its unique perspective, its specialized knowledge to the vast and interconnected understanding of our world. From the smallest crystal to the grandest mountain range, from the depths of the oceans to the core of the Earth, geology offers a lens through which we can perceive the intricate mechanisms that govern our planet. It is a discipline that constantly reminds us of the Earth's power, its resilience, and indeed its fragility in the face of ongoing change. So, prepare to embark on an expedition into the heart of our planet. We shall venture into the realms of shimmering minerals, ancient fossils, and the very processes that sculpt our landscapes and drive the engine of our world. This is more than an academic pursuit. It is an invitation to connect with the Earth on a profound level, to appreciate its complexities and to marvel at the sheer elegance of its natural systems. Our exploration begins now into the diverse and captivating disciplines that collectively tell the Earth's magnificent story. Our first foray takes us into the glittering realm of mineralogy. Here we delve into the fundamental building blocks of our planet, the minerals. These are not mere stones, but naturally occurring solid chemical substances, each with a precise ordered atomic structure and a distinct chemical composition. They are the alphabet of geology, forming the rocks beneath our feet, the soils that sustain life, and the precious gems that have captivated humanity for millennia. From the common quartz that sparkles in a granite countertop to the rarest diamond forged in the Earth's mantle, each mineral tells a story of its fiery birth, its journey through immense pressures and temperatures, and its eventual arrival at the surface. Their colors, their luster, their very forms are testament to the intricate laws of chemistry and physics that govern their creation. Mineralogists, then, are the meticulous archivists of these earthly treasures. They dedicate themselves to understanding how these remarkable substances form, often in environments of extreme heat and pressure, or through the slow precipitation from ancient waters. They painstakingly examine their physical properties, hardness, cleavage, crystal habit, and probe their complex chemical makeup. This study is crucial, for it is through understanding minerals that we can decipher the conditions of Earth's past, locate valuable resources, and even predict how materials will behave under different stresses. Every facet of a crystal, every streak of color holds a clue, a piece of the grand puzzle that is our planet's composition and history. We now turn our attention to petrology, the study of rocks, the very bedrock of our world. Rocks are not static, lifeless things. They are dynamic entities, aggregates of one or more minerals, each bearing witness to the geological processes that have shaped our planet over eons. Consider the fiery birth of igneous rocks, crystallized from molten magma or lava, like granite forming deep within the earth, or basalt erupting from volcanoes. Then there are the sedimentary rocks, like sandstone or limestone, formed from the accumulated fragments of older rocks or the remains of ancient life, settled and compacted in layers over vast stretches of time. And finally, the metamorphic rocks, such as marble or slate, transformed by intense heat and pressure, their original structures and mineralogy contorted and recrystallized into new forms, revealing the immense forces at play within the Earth's crust. Petrologists, therefore, are like historians reading the chronicles embedded within these stony archives. They investigate the origin of rocks, seeking to understand the conditions under which they were created, whether in the heart of a volcano, the depths of an ocean, or the core of a mountain range. They meticulously analyze their composition, identifying the constituent minerals and their chemical signatures. The structure and texture of a rock, its fabric, provide further clues about its journey, its history of heating, cooling, burial, and uplift. By studying the distribution of different rock types across the globe, petrologists piece together the grand narrative of continental drift, mountain building, and the ever-evolving surface of our Earth. Our journey now leads us into the intricate world of geochemistry, a discipline where the principles of chemistry are applied to unravel the Earth's most fundamental processes and compositions. Imagine our planet as a vast, dynamic chemical laboratory where elements are constantly interacting, transforming and cycling through its various spheres, from the molten core to the atmosphere, from the deepest oceans to the highest mountains. Geochemistry seeks to understand the distribution and migration of these elements, the isotopes that act as natural traces, and the chemical reactions that drive geological phenomena. It is the science that asks, what is the Earth made of? And how do these materials behave and interact on a chemical level, shaping the planet we know today? Geochemists, armed with sophisticated analytical tools, are the detectives of this elemental dance. They trace the pathways of elements through rocks, waters, soils, and even living organisms, seeking to understand everything from the formation of mineral deposits to the evolution of our atmosphere and oceans. By analyzing the isotopic signatures in ancient rocks, they can date geological events with astonishing precision and reconstruct past environmental conditions. Geochemistry plays a vital role in exploring for natural resources, monitoring pollution, understanding climate change, and even shedding light on the origins of life itself. It provides a fundamental chemical fingerprint of our planet, revealing the intricate balance of its systems. Chapter 4, Geophysics, Probing the Earth's Hidden Depths. We now venture into the realm of geophysics, a field that employs the laws and techniques of physics to explore the Earth's largely inaccessible interior and its grand dynamic processes. Beneath the surface we inhabit lies a world of immense pressures and temperatures, a layered structure from the crust through the mantle to the core, all governed by physical forces. Geophysics allows us to see into these hidden depths, to understand the Earth's gravitational and magnetic fields that extend far into space, and to study the powerful seismic waves generated by earthquakes, which act like natural sonograms, revealing the planet's inner architecture. It is through geophysics that we comprehend the immense engine-driving plate tectonics, the very force that shapes continents and oceans. Geophysicists are, in essence, planetary diagnosticians, using an array of sophisticated instruments and techniques to listen to the Earth's heartbeat and map its internal structure. They deploy seismometers to record the faintest tremors, magnetometers to chart the subtle variations in the Earth's magnetic field, and gravimeters to measure the pull of gravity, which can reveal variations in density beneath the surface. These observations help us to understand the convection currents in the mantle that drive the continents, the generation of the Earth's protective magnetic shield in the outer core, and the mechanisms behind earthquakes and volcanic eruptions. Geophysics provides the blueprint of our planet's interior, a crucial piece in understanding its overall behavior. Chapter 5, Paleontology, Echoes of Ancient Life. Our exploration now takes us back in time, deep into the annals of Earth's history, through the captivating lens of paleontology. This is the science of ancient life, a discipline dedicated to uncovering and interpreting the fossilized remains of organisms that lived millions, even billions of years ago. These fossils, from the delicate imprints of primeval ferns to the colossal bones of dinosaurs, from microscopic single-celled organisms to the ancestors of humankind, are precious windows into bygone eras. They provide tangible evidence of evolution, charting the incredible journey of life from its simplest origins to the breathtaking biodiversity we witness and have witnessed on our planet. Each fossil is a snapshot, a fragment of a lost world, holding clues to ancient ecosystems and the very processes of life's unfolding drama. Paleontologists are the tireless excavators and interpreters of this ancient record. Their work often begins in the field, patiently searching rock strata for telltale signs of past existence, carefully extracting fragile specimens from their stony tombs. Back in the laboratory, they meticulously clean, prepare, and study these remnants, comparing them with living organisms and other fossils to understand their anatomy, their relationships, and their place in the tree of life. Through their efforts, we can reconstruct ancient environments, understand past climates, trace the migrations of species, and witness the profound impact of extinction events. Paleontology doesn't just tell us about past life, it informs our understanding of life's resilience, its adaptability, and its interconnectedness throughout Earth's long history. Chapter 6, Structural Geology, the Architecture of Earth's Stresses. We now delve into structural geology, the discipline that investigates the architecture of rocks, focusing on their deformation. The Earth's crust is not a static shell, it is a dynamic entity, constantly subjected to immense tectonic forces. These forces, originating deep within the planet, can compress, stretch and twist rocks, leading to the formation of spectacular geological structures. Imagine vast layers of rock, once horizontal, now bent into intricate folds, like colossal wrinkles on the Earth's skin. Picture immense fractures, known as faults, along which rock masses have slipped past each other, sometimes catastrophically generating earthquakes. And consider the myriad joints and fissures that pattern rock faces, pathways for water and mineral deposition. These are the features that structural geologists study. The task of the structural geologist is to map, analyze, and interpret these deformational structures. They meticulously measure the orientation of folds and faults, examine the microscopic fabrics within deformed rocks, and use this information to reconstruct the history of stresses and strains that the rocks have endured. This understanding is not merely academic, it has profound practical implications. It helps in locating deposits of oil, gas, and mineral ores which often accumulate in specific structural traps. It is crucial for assessing the stability of slopes, the safety of tunnel and dam construction, and for understanding seismic hazards. Structural geology reveals the immense power locked within our planet and the ways in which it has shaped the very landscapes we inhabit. Chapter 7. Our journey now takes us beneath the surface, into the often unseen but vitally important realm of hydrogeology. This branch of geology is dedicated to the study of groundwater, the water that exists in the pores and fractures within rocks and sediments beneath the Earth's surface. While rivers and lakes are conspicuous, a vast reservoir of fresh water, far exceeding that on the surface, lies hidden from direct view, slowly percolating through subterranean formations known as aquifers. This groundwater is a critical resource, sustaining ecosystems, providing drinking water for billions of people and supporting agriculture in arid and semi-arid regions across the globe. Its movement, though slow, shapes landscapes and influences the chemistry of both water and rock. Hydrogeologists are the guardians and explorers of this hidden resource. They investigate how groundwater originates, typically from rainfall infiltrating the ground, how it moves through different geological materials, and where it accumulates. They use techniques such as drilling wells, conducting pumping tests, and employing geophysical surveys to map the extent and properties of aquifers. Their work is essential for locating sustainable water supplies, for predicting the impact of withdrawals on groundwater levels and connected surface waters, and for protecting this precious resource from contamination by pollutants. Understanding the intricate dance between surface water and groundwater is paramount for managing our planet's finite freshwater reserves in an increasingly thirsty world. Chapter 8. We now explore economic geology, a field that directly connects the Earth's geological processes with the material foundations of human civilization. Our planet is endowed with a vast array of materials that have economic value, from the metallic ores that yield iron, copper, gold and aluminum to the fossil fuels like coal, oil and natural gas that power our industries and homes, and the industrial minerals such as aggregates, clays and limestone used in construction and manufacturing. These resources are not randomly distributed. Their formation is intrinsically linked to specific geological environments and processes that have occurred over immense timescales, concentrating these valuable substances into economically viable deposits. Economic geologists are the prospectors and analysts who apply geological principles to discover, evaluate, and facilitate the extraction of these earth materials. Their work involves detailed geological mapping, geochemical surveys, geophysical exploration, and the interpretation of drill core data to identify and delineate ore bodies or hydrocarbon reservoirs. They must understand the complex geological controls that led to the concentration of these resources, whether it be magmatic processes, hydrothermal activity, sedimentary deposition, or weathering and enrichment. As societies strive for sustainable development, economic geologists also play an increasingly crucial role in assessing the environmental impact of resource extraction and in finding new sources of critical minerals needed for green technologies. Chapter 9. Engineering geology building on solid foundations. Our focus now shifts to engineering geology, a practical and vital discipline that applies geological knowledge to engineering and construction projects. Whenever we build structures, be it towering skyscrapers, expansive bridges, lengthy tunnels, or massive dams, we are interacting directly with the Earth. The ground beneath these structures is not uniform. It comprises different types of rock and soil, each with unique properties regarding strength, stability, and permeability. Understanding these geological conditions is paramount to ensuring the safety, stability, and longevity of any engineered works, protecting both investments and human lives from geological hazards. Engineering geologists are the crucial intermediaries between the Earth's natural complexities and the demands of human construction. They conduct thorough site investigations, drilling boreholes, testing soil and rock samples in laboratories, and assessing geological hazards such as landslides, sinkholes, earthquakes, and soil liquefaction. Their expertise informs the design of foundations, the excavation of slopes, the routing of tunnels, and the selection of construction materials. By providing this critical geological input, they help engineers to design structures that can withstand the forces of nature and to mitigate risks associated with challenging ground conditions, ensuring our built environment is as safe and resilient as possible. Chapter 10. Environmental Geology, Healing and Protecting Our Planet. We now arrive at environmental geology, a field of profound contemporary relevance that applies geological principles to understanding and mitigating environmental problems often caused by human activities. Our planet's geological systems, its soils, waters, and underlying rocks are intimately connected with the health of ecosystems and human societies. Activities such as mining, waste disposal, industrial processes, and intensive agriculture can lead to contamination of groundwater and soil, trigger land subsidence or erosion, and alter natural geological processes. Environmental geology seeks to understand these impacts and to find sustainable solutions for coexisting with our planet. Environmental geologists act as planetary stewards, using their knowledge to address a wide array of challenges. They investigate the extent and migration of pollutants in the subsurface, design safe landfill sites, and advise on the remediation of contaminated land. They assess the geological aspects of land use planning, helping to avoid development in areas prone to natural hazards or with sensitive ecosystems. Furthermore, their understanding of past climate change, as recorded in geological archives, provides crucial context for addressing current global warming. Environmental geology is thus at the forefront of efforts to ensure that human development proceeds in a way that minimizes harm to the Earth's delicate systems and preserves resources for future generations. Chapter 11. Geomorphology, Sculptors of the Earth's Surface. Our final chapter in this geological exploration brings us to geomorphology, the captivating study of the Earth's surface, landforms, and the dynamic processes that create and shape them. Look around you, the majestic rise of mountain ranges, the sinuous paths of rivers carving valleys, the dramatic cliffs and gentle slopes of coastlines, the vast expanses of deserts with their shifting dunes, and the sculpted terrain left by ancient glaciers. These are not static features, they are the result of a continuous interplay between internal Earth forces such as uplift and volcanism and external forces driven by climate and gravity, like weathering, erosion, and deposition by water, wind, and ice. Geomorphologists are the interpreters of these landscapes, reading the stories etched into the Earth's surface. They investigate how rivers erode their channels and build floodplains, how glaciers carve U-shaped valleys and deposit moraines, how wind sculpts desert landscapes, and how coastlines retreat or advance under the influence of waves and changing sea levels. By studying these processes, both past and present, geomorphologists can understand how landscapes have evolved over time, predict future changes, and assess hazards such as flooding, landslides, and coastal erosion. Their work provides a profound appreciation for the ever-changing canvas of our planet, a surface constantly being reshaped by nature's relentless artistry. Outro the ongoing adventure of discovery. Thank you for joining us on this exploration of geology's many branches. We have journeyed from the heart of crystals to the grand sweep of mountain ranges, from the echoes of ancient life to the vital hidden rivers beneath our feet. It has become clear, I hope, that geology is not a singular, monolithic subject, but a rich tapestry woven from many interconnected threads of inquiry. Each branch, with its unique focus, contributes to a more complete and profound understanding of the Earth, its history, its processes, its resources, and indeed its future. The knowledge gleaned from these diverse fields is more critical now than ever before. As we face global challenges such as climate change, resource scarcity, and environmental degradation, it is the insights from geology that can help us navigate these complex issues, fostering a more sustainable and informed relationship with our planet. Understanding the Earth's systems allows us to anticipate hazards, manage resources wisely, and appreciate the delicate balance that sustains life. The story of our planet is still being written, and geology provides us with the tools to read its current chapters and perhaps to influence those yet to come. So, as our journey for today concludes, I urge you to carry this sense of wonder with you. Look at the landscapes around you with new eyes. Consider the immense history beneath your feet and appreciate the intricate workings of this remarkable world. Stay curious and keep exploring the wonders of our planet. For the Earth holds countless more secrets waiting for those with an inquisitive spirit and a desire to understand. The adventure of discovery is truly without end.